trying to find the distance of each data point from the centroid, Euclidean distance formula will be better. So we discussed already Euclidean distance formula. Using that formula, we are going to find the distance of each data point. So if I'm finding the distance of each data point, so first time I'll find for what? For this will find for this. So it will be what? My data point is 1. Okay, distance of first centroid of first component. So data point is nothing but what? D11. Data point is 1. 1 minus my centroid value is 1.568. So 1 minus 5.68 whole square. Okay, we have mentioned here plus. Now I'm talking about 3. 3 minus 4.015 whole square, and you will solve this one and you will get the result which is 1.1. Sorry, 1.2. So this is your first distance of each data point from centroid. So you are finding the distance of 1 from this, and the same way you are finding the distance of 3 from this. You have done this. Next time what you have to do, now the same one you have to find the distance of 1 with this, as well as you have to find the distance of 3 with this. So same way you have done this one. So you are finding D12, which is 1 minus 5.35 whole square plus 3 minus 8.215 whole square, and when you will solve this one, it will become 6.79. Now the same thing you need to repeat for what? You need to repeat for this data point 2 and 5. Now you have to find the distance of this 2 with first value and distance with 5 with this centroid value. Okay, and the same way you have to repeat. So this will become what? D21, and when you keep this value, result will be 1.04. Now you will find what? D22. When you are finding D22, it is what? You have to find the distance of 2 with 5.35 and distance of 5 with 8.215. So this will become what? D22. Your result is 4.64. Now, the same way you have to repeat for the data point. You have to repeat the same step for data point 4 and 8, and the same way you have to repeat for 7 and 9. So which will be your D31, D32 for 4 and 8, and D31 and D32 for your 7 and 9. So I hope it is clear to you that how we are finding the distance of each data points from the centroid. So we have identified in the step 3, we have identified the distance of each data point from the centroid. And now we have identified the distance of each data point from the centroid. Now what is the use of finding the distance of each data point from the centroid? So what we have to do, wherever we have less distance, one second. So what we are saying, this particular data point 1, 3 belongs to which cluster? So here the distance is, where distance is less. You can see here distance is 1.2 in this case. In the case of this, if I'm saying data point 1, 3, the distance is 1.2 from the centroid, and in this case distance is 6.79. It means this particular data points belongs to which cluster? It should belongs to cluster 1. So we have updated that it should belongs to cluster 1 because here the distance is less. The same way, if you will see 2, 5, the distance from the centroid is 1.04. Distance from this centroid, it is 1.04, and distance from the second centroid, it is 4.64. So where the distance is less? Distance is less for centroid 1. So we'll say that this data point belongs to centroid 1. Clear? That's why I've written here 1. The same way we have to find this value. So you can see here 4, 8. When I'm talking about 4, 8, so distance from the first centroid is 4.63 and distance from the second centroid it is 1.36. So distance where we have less distance from the second centroid, that's why we have written 2. The same way for this particular data point 7 and 9, we have the distance from the first centroid which is 7.34 and for the second centroid it is 1.82. So we have less distance from the centroid 2. That's why we are getting that this particular data point must belongs to cluster 2. So in this way we are calculating the distance and we are finding that this particular data point should belongs to which particular cluster. Okay, now I have to update the membership. I in the first step, in the very first step, if you remember, we have taken the membership table which is randomly generated. Now using these distance which I have calculated here, using these distances I have to update the membership values. So to update the membership value or to get the proper probability of every data points belongs to a particular cluster, I have to use this formula, which is nothing but we are updating the membership values. So formula is Vik equal to summation of I equal to 1 to n. So n is nothing but number of clusters here. Fine. Now dki square divided by dkj square. So I and k, I is nothing but I is constant here and k is nothing but your data points. Okay, k is your data points. Whatever data points we are having, that is nothing but your data points. 1 divided by m to the power m, 1 divided by m minus 1 and the power of whole power of minus 1. So m is nothing but m is here 2. So I have to keep the values in this formula to update the membership table. So what I have to do? So first time my k value is, k is nothing but my data point. So my data point is nothing but what? The first time my data point is, I'm talking about this particular data points. I'm talking about this data point. I have to update for this data point. So what is the probability of this data point belongs to cluster 1 and cluster 2? I have to find this value. So what I'm writing here, mu11 equal to, okay. So what is my D here? DIK. So what is my 1 and what is my I here? I is first time 1 and K is also 1. So D11 is nothing but 1.2. So we kept the value 1.2 whole square divided by what? dkj. So dk, k is 1 again and j is also 1. I is constant here. So 1.2 square plus next time. So how many times it will be repeated? It will be repeated 2 times because we are talking about 2 clusters. Fine. So again if I keep these values, so this 1.2 will remain same because dki is nothing but d11. So it will be 1.2 whole square divided by dkj. Dkj is nothing but now j value is what? J value is nothing but j is representing here number of clusters. So we are talking about the second cluster. First time we are talking about the first cluster. Now I'm talking about the second cluster. So D, it will become what? DKJ. DKJ is nothing but 1 comma 2. So D12 is what for me? D12 is 6.79. So we are dividing with 6.79 square and the power of this is what? 1 divided by m. M is 2, 2 minus 1 and whole to the power minus 1. When you will solve this, it will become 0.97. So what it is showing that when I am keeping these value into the formula, what it is saying that data point, there is a probability of 0.97 that this particular data point belongs to cluster 1. So this 0.8 must be replaced with 0.97. So the probability of the data point 1 comma 3 belongs to cluster 1 is 0.797. Now earlier it was 0.8 which we have written randomly. Now the same way I have to find for cluster 2. The probability of data point 1 comma 3 belongs to cluster 2. I have to find. So again I will do the same thing and I'll keep the values in the formula. So this will become what for me? Y12. Y12 when I am keeping here. So Y12 is nothing but we are saying D12 whole square which is 6.79 and divided by D11. D11 is 1.2 plus D12 is 6.79 and as j value will change here, j value will change, it means what? 6.79 square and when I keep everything in the formula, the probability will be 0.03. So that this value will be replaced by 0.03. Now you can see here the sum of 0.97 and the sum of 0.03 will be equivalent to what? 1. And I told you earlier that these two values must be equivalent to 1. Now what it says, the probability of 1 comma 3 belongs to cluster 1 is 0.97 and the probability of 1 comma 3 belongs to cluster 2 is 0.03. The same way I have to update these values also. So I'll repeat the same step here and we'll update the whole table. So when we are going to update the whole table, you will get the final outcomes. Okay, so you are going to find out mu21 and mu22. Mu21 and mu22 is nothing but for this particular data point. For this particular data point, you are going to find, you have to find the new value for this and you have to find the new value for this. So new value is 0.95 and for this it is 0.05. Same way you have to repeat the same thing for this as well as you have to repeat the same step for this. So I'll request you people, you do this calculation with your own so you will have a better understanding. Okay, so do the calculation for at least one or two clusters, then you will understand in a better way that how the calculation has been done. So we will update all these values and after updating we'll get the final outcome. So this is my final outcome after updating all 4 new membership values. So this is my new membership table which I got after updating the membership values. So this is my step number 4. So now I got new membership values. Now how many times I should update membership table? That is a question here, that how many times I should update this table. So until and unless, after every updation, until and unless I'm not getting the constant values, I have to repeat the step number 2 to 4. I have to repeat step number 2 to 4 until and unless I'll not get constant values. Or we can take this also, where the difference is less than the tolerance value. We'll stop the updation. Suppose I'm saying the difference, my tolerance value is 0.01. So if difference is less than 0.01, if difference is less than 0.01, whenever I'm updating, the difference is coming less than 0.01, then I'll say I'll stop the updation. I'll stop there itself and that will become my final cluster. Okay. Now see here, earlier what was the value? Probability was 0.8 and now it is what? 0.97. So difference is what? More than 0.1. 0.01. So we can say that this updation is mandatory. The same way here the updation is what? 0.22. It became what? 0.03. So here also the difference is high. So we have to repeat the same step. So again we'll repeat step number 2, 3 and 4 and we'll try to find the final clusters where we can say that after every updation now we are getting the constant result or the membership values or the difference is less than the tolerance value, then we'll stop the repetition process and we'll say this is my final outcome of the algorithm. So this is all about your fuzzy C-min algorithm. So I hope it is clear to you that how fuzzy C-min algorithm works. So your fuzzy C-min algorithm is divided into how many steps? 4 steps, 5 steps. So we have discussed the first step is nothing but we are initializing the random values in the membership table, that we are saying that every data points having a probability belongs to cluster 1 and cluster 2. So first step is we are preparing the membership table. In the second step we are finding the centroid. Okay, we are finding the centroid. Once the centroid has been found out in the second step, now we have to find out the distance of each point from the centroid. And using that distance, we will find out that that particular data point belongs to cluster 1 or cluster 2. After finding the distance of each data points to the centroid, now I have to find out, update the membership values. And how many times I do this updation? Until and unless, how many times I have to do this updation? Until and unless the obtained values are not constant or it must be less than the tolerance value. I have to repeat step number 2 to 4. So this is all about fuzzy C-min algorithm. I hope it is clear to you. Thank you so much. With this, we have finished third unit. Okay. Thank you.